I will solve now exercise 4 part B, which asks us to find an inverse for the function f of x equals x minus 2 squared. The first step is to find a restriction of the domain of f on which the function is 1 to 1. We can see that if we restrict the domain to 2 to infinity, then on that part of the graph, the function is 1 to 1. So we restrict the domain of f to 2 infinity. That's the first step. We need to find the restriction of the domain on which the function is 1 to 1. And we found it. Now we move to step 2, which tells us to replace f of x with y. So that means we simply write y equals x minus 2 squared. Step 3 is to interchange x and y. So I'll set x equals y minus 2 squared. And now step 4 is solve for y. What does that mean? We want to end up with y equals something. Okay. So how can we do that? Well, because we have y minus 2 squared, what we can do in the first step is to take the square root of both sides. So we have square root of x equals, and now y minus 2 is, remember, this is the old x, so this is a positive value because we restrict it to interval to infinity. So this is simply going to be y minus 2. And because this is a positive quantity, we don't need to worry about taking the case where we have minus square root of x. Okay, well now it's relatively easy. We add 2 on both sides and we end up with square root of x plus 2 equals y. And now we are up to step 5, which tells us that we simply replace y with f inverse of x. So f inverse of x equals square root of x plus 2. And that is our inverse. And finally, in step 6, we have to think about the domain of f inverse of x. In this case, because we take the square root of x, we need that x to be greater or equal to 0. So the domain of f inverse is the interval 0, 0 to infinity. Here we can see in red the graph of f restricted to the interval 2 to infinity. So in red we have y equals x minus 2 squared. In blue we have f inverse, which is the graph y equals square root of x plus 2. And I've shown in green the first diagonal, which is y equals x, and we can see that the two graphs of f and f inverse are symmetric with respect to the first diagonal.